All right, inverse trig functions and differentiation. Develop properties of the 6 inverse trig functions, differentiate an inverse trig function, and review basic differentiation rules for elementary functions. All right, guys, so we need to restrict our domain of a trig function so that it would be one-to-one. Remember that a sine graph goes on forever. So if I was to restrict it, I need to restrict it somehow so that it is one-to-one, meaning strictly monotonic or strictly increasing or decreasing. So if I took it from right here from negative pi half to positive pi half, that would always be increasing. Once I get past that, it's decreasing, or over here. So therefore, that would be restricted from negative pi half to pi half. The cosine graph. If I restrict from 0 over here to pi, actually, I'm sorry, that would be 0 to 2 pi. That's not one-to-one. But if I go 0 to pi and stop here at pi, that would be strictly decreasing. That would be strictly monotonic, and therefore it would be one-to-one from 0 to x is pi. Tangent of x. I don't want to cross that asymptote for the one-to-one, so I would go from negative pi half to pi half, and that would make this be also one-to-one. So again, this is where they are restricted to make them be one-to-one. Okay. So these are the graphs of your 6 inverse trig functions. Excuse me. If you took the graph of the sine of x and then you turn it sideways, it goes like this. The graph of the cosine of x would do that. The graph of the tangent can get easier. That one's a little easier to see it turn sideways there. So evaluate it. When is the arc sine negative 1/2? So the arc sine, that's asking me when is the sine negative. Well, is that going to be in quadrant 1 or quadrant 4? See, that would be in quadrant 4. And then when is the sine 1/2? So, again, inverse cosine and cotangent are in the top 2 quadrants. Inverse sine and tangent are in the right 2 quadrants. So when is the sine negative? That was going to be down here. So my answer is going to be a negative whatever in the sine to be 1/2. So I'd have to figure out when is the sine 1/2. And the sine of 1/2 is reference angle is 30 degrees, which is pi 6. So therefore my answer would be negative pi 6 for this arc sine to be negative 1/2. All right, for arc cosine to be negative, it's going to be over here into quadrant 2. And when is the cosine radical 3 over 2? So the cosine to be radical 3 over 2 is going to have a reference angle of 30 degrees. But that's going to put me over here. So reference of 30 is going to be 150. So 30 times 5 is 150. That's where this 5 comes from. 30 is pi 6, so therefore 5 pi 6. So when is the tangent radical 3? So again, inverse tangent is going to be positive in quadrant 1. When is the tangent radical 3? Some of you might need to stop and actually draw your 30, 60, and 45 right triangles. I'm assuming at this point that you know those. If you do not, come see me and I'll help you with that. So when is the tangent radical 3? So again, you'd have to ask yourself what angle that would be. That would be at 60 degrees, which is your pi thirds. And therefore in quadrant 1, that's just going to stay pi thirds. It's its answer. Now this one would be unable to be done without a calculator, so you would make sure this mode is set in or radian mode, and you would just type the second sine, inverse sine of 3/10 to get your decimal answer. So D will not be on my test, but A, B, and C will be. All right, given y equals the arctangent of x, fill in the table. So this is x is negative radical 3. That goes right there. So this first one's saying y equals arctangent of negative radical 3. The second one, that's y. So negative pi 6 equals arctangent of x. And then again, pi fourth for the y equals arctangent of x. We have to understand if we're plugging in for the x or the y first. Now, the arctangent is negative down into quadrant 4. And we ask ourselves the tangent of what angle is radical 3 over 1. So the tangent of 60 degrees is. But to go down to quadrant 4, you'd have to go to negative 60 degrees, which is negative pi thirds. So that would be negative pi thirds. All right, this one's asking me the tangent at negative pi 6. Negative pi 6 puts me into quadrant 4. That means I want the tangent at 30 degrees. So the tangent at 30 degrees is going to be 1 over radical 3. And because it's in quadrant 4, the answer will be negative. Again, in quadrant 3, the tangent and the sine are both negative. This one's asking me for the tangent at pi fourth. That means the tangent at 45 degrees. The tangent at 45 degrees is going to be 1 over 1. So the answer would be 1. So inverse functions and their properties. So remember, if you plug in the inverse into f or f into the inverse, they both have to equal x. Okay. But it has to be within these domains. So for example, the arc sine of the sine of pi. See, the sine at pi is 0, but the inverse of sine of 0 is at 0. It's not pi. So do be careful that if you have arc sine of pi, in that situation, it would not be the answer of pi. Most of the time it is, but in this case it is not, because it's not in the original domain. The pi is not in the original domain of the arc sine. That's what they're trying to tell you here. So we need to solve for x. I need to get rid of this word arctangent, so I'm going to take the tangent of both sides first. So the tangent of the arctangent, that's gone. It gives me 2x minus 3 equals the tangent at pi force. That means the tangent at 45 degrees. That's 1. Add 3 and divide by 2. All right, given y equals the arc sine of x, find the cosine of y. So this tells me the sine of y equals x. The sine of some angle equals x. So the sine of some angle is the opposite over hypotenuse. Pythagorean theorem. Now I want the cosine of this angle. So the cosine is adjacent over hypotenuse. This says the secant of y equals radical 5 over 2. The secant is the reciprocal of the cosine. So the cosine of some angle is adjacent over hypotenuse 2 over radical 5. Pythagorean theorem, I get 1 for the opposite side. Now I want the tangent of this angle. The tangent would be 1 over 2. I want the tangent of the arc cosine of radical 2 over 2. So this is telling me the cosine of some angle is radical 2 over 2. So cosine adjacent over hypotenuse. Do your Pythagorean theorem. So I want the tangent at that angle. So I had to figure out this side. The tangent would be radical 2 over 2, which would be 1. So I need the cosine of the arc sine of 5/13. So this first part right here says the sine of some angle is 5/13. So the sine is opposite over hypotenuse. Now I want the cosine of that angle. So Pythagorean theorem, the side is 12. Cosine is adjacent over hypotenuse, so it would be 12/13. Again, I want the cosine of the arc sine of 4x. This says the sine of some angle is 4x. That means the sine of some angle is 4x over 1. I want the cosine at this angle. I need this side. To get this side, it'd be Pythagorean theorem of 1 minus the 4x quantity of 4x squared, and then the square root of that. So the cosine of that angle would be the adjacent over the hypotenuse. This time I want the tangent of the arc secant of x over 3. Well, secant is the reciprocal of the cosine. That means the cosine of some angle is 3 over x. So the cosine of some angle is 3 over x. So let's look at that picture. And see, now I want the tangent of that angle. So the cosine of the angle, 3 over x, Pythagorean theorem, this would be square root of x squared minus 9. Now I want the tangent at that angle, so opposite over adjacent leg. And there we go. So what if I want the derivative of the arc sine of u? So we're going to let theta equal the arc sine of u first. This says the sine of some angle equals u. Well, the derivative of the sine is the cosine of theta. Okay, or I could look at the picture. The sine of theta is going to be u over 1. Got my Pythagorean theorem. Now, the derivative of the sine is the cosine of theta d theta. The derivative of u is du. Guys, so this derivative right here, if I divide by cosine theta, it's du over cosine theta. But see, the cosine of theta is that square root over 1. And there's my rule. So again, we're looking into some proofs of derivatives of the arc sine of u, arc cotangent, arc sec, all these different arcs. So the derivative of the arc sine of u is right here. Now this is on a pink formula sheet that we will give you in class. So please ask me for the formula sheet if you haven't picked one up already. All right, so I want the derivative of the arc cotangent of u. So again, we're going to start with the theta equals the arc cotangent. That means the cotangent of theta equals u over 1. That means tangent of theta, the tangent then would have been 1 over u. So in terms for the picture. All right, square root of u squared plus 1 squared, Pythagorean theorem. The derivative of the cotangent, negative cosecant squared, d theta, derivative of u. Again, I want to look for this d theta, so d theta is going to equal, divide by that negative cosecant squared. Well, if I have cosecant squared on bottom, that would be sine squared on top. Now, the sine of this angle is 1 over that denominator, but I'm going to square that, so I have a negative. The the sine of the angles here squared d theta, or du. So when you square that, here's your formula. Again, like I said, these are on a pink sheet that you will be given on your final exam, but I want you to understand where the rules came from, especially if you're going on to Cal 2. You really need to know where these come from. And so all 6 of these are given to you on your formula sheet. Now let's use them. All right, so the derivative of the arc sine of t to the 6th. So on that pink sheet, this is going to be the u prime, which in that case, my u is t to the 6th. So that would be 6t to the 5th. Square root 1 minus t to the 6th squared would be t to the 12th. That would be my answer. So this one, I have 3 times the derivative of your arc cosine. Because that 3 is a coefficient, I need to use this arc cosine rule. So my u is 1/4 of x. So its derivative would be 1/4. So this would be a negative 1/4. Boom. 1 minus my u squared. But guys, I can't have fractions within fractions. We got to figure out how to work that. All right, so I'm going to multiply the top by 4 and the bottom by square root of 16. That's still a 4. See, 4 over 4 is 1. That's a big old fancy 1. So 4 times this would be negative 1 times that 3. Square root of 16 times that 1, square root of 16, and that 16 with this would be the x squared. And that's where we get the final answer from. To do the next product, you're going to have to know to do the product rule. You're going to do x squared separate from the arc tangent of 3x. So here's my x squared. Here's my arc tangent of 3x. For this one, we use this rule. U prime, that would be 3. U squared is 9x squared plus 1. Cross, multiply, add, and you're done. Find the derivative of the arc sine of x plus x square root of 1 minus x squared. So that's just a simple pink sheet rule. That is going to be a cross, multiply, add product rule problem. Okay, so there's my x. There's my square root of 1 minus x squared. Its derivative. Simplify it, cross, multiply, add. And for that one, arc sine, plug into that first one right there. Now that looks like a mess that we need to simplify. All right, so this one's good. This one, these twos reduce. That's an x squared, negative, and that moves to the denominator. So hopefully you caught that. Again, those twos reduce. There's my negative x times x, negative x squared. Okay. Now, guys, these two, I hope you're noticing those have a common denominator already. So that numerator would be a 1 minus x squared over that bottom. What if I went ahead and got a common denominator between these two? The homework system probably accepts that. Multiple choice, that's not your answer. So I get this with the common denominator, multiply top and bottom by square root of 1 minus x squared. So if I was to do that, then this numerator would be 1 minus x squared plus 1 minus x squared over a square root of 1 minus x squared. Kind of gets really messy. So instead what they did was they went ahead and said, well, this expression right there actually simplifies to this right here. So they left that one alone. This is 1 minus x squared to the first power. This is 1 minus x squared to the 1/2 power. Let's back that up for just a second. Let's say I have b over the square root of b. Let's go something simpler first. So b, can't see it hardly. b over the square root of b. See, that's b to the 1. That's b to the 1/2. I would take 1 minus 1/2, and that would become b to the 1/2 on top. And that's what they've done, guys. All of this binomial to the 1, this binomial to the 1/2. 1 minus 1/2 would be 1/2 right there. Now I have 2 of these radicals, so it'd be 2 radical 1 minus x squared. And like I said, in your homework system, this is fine. I'm sure it's going to accept that. If it doesn't, then you just need to finish off simplifying it. All right, we need to find this derivative. I'm looking at that going, oh, this looks horrible. This looks like a big mess. All right, that is just a 5/2. That's just a coefficient. That is also a coefficient, but this I can separate. Natural log of x plus 1 minus natural log of x minus 1. That's a rule off your new pink sheets. See, if we can even understand what we have going on here, it will really help y'all. So that stays your 5/2 for the derivatives. That's your 1/2. 1 over x plus 1 minus 1/2 coefficient. 1 over x minus 1. Then that is up there in the corner or on your pink sheet for its derivative. And it's finished. If they have you simplify it, which they won't, but I know some people are going on to further math classes. That would be 2 times. This would need an x minus 1. This would be a 2 times. This needs a x plus 1 to make these two have a common denominator for those two fractions. Now that those two fractions have a common denominator, I want you to look at the numerators. So this would be x minus x. Those are gone. Negative 1 minus 1. Well, that'd be negative 2. Over this 2. So those would reduce to a negative 1 over that bottom. Now we could turn around and get a common denominator between these two fractions and simplify from there. So do you see how that answer is actually simpler than this answer? This is correct and it accepts it. Open response, I would accept it. Multiple choice is going to be that. So you might want to practice all the way down to the final solutions while you're doing your homework, because you do know you're going to have part multiple choice and part open response test. All right, need to take the derivative again. So arctangent of x over 8. Then this piece here would be chain rule. I just think that as a half, and that's that binomial to the negative 1. So this right here, my u prime will be 1/8, and the u squared plus 1. This derivative, negative times that negative, positive a half, everything there to the negative 2. Derivative of what's in there is a 2x. These 2's reduce, so I have x over that squared, but I can't have this fraction within fraction. Multiply the top by 64, the bottom by 64. So that gives me an 1/8 of 64 is 8. 64 times that, 64 times 1. And again, the 2's reduced, that dropped to the bottom, the x stayed on the top. All right, if we get a common denominator, because multiple choice goes on, that one needs an x squared plus 64, because it only has one set. This is a binomial squared. So now we distribute, add like terms, and there is our other answer. Find the extrema, that means to find the derivative when it is equal to 0, and find when it's changing values. So, take my derivative. Got to do chain rule, 2 times arctangent to the first times the derivative of the arctangent from the pink sheet. So there's my numerator, there's my denominator. I need to know when the numerator is 0 and when is the denominator undefined. That denominator is never undefined. When is the arctangent 0 is what we're looking for that numerator. The arctangent is 0 when y over x is 0 on that unit circle. That would be when x is 0. So I have a critical number of 0. Now I have to plug in around that to see if it's positive or negative. So on the bottom here, those are always positive. A number squared plus 1 will always be positive. So I just need to know 2 times the arctangent of, say, negative 5 versus 2 times the arctangent of positive 5. Which ones are positive and which ones are negative? Now, your tangent graph to your arctangent graph, I'm going to draw both of those, so give me just a second here. So tangent, and now arctangent. Okay, so the first graph I have drawn is the tangent graph from negative pi half to pi half. This is the arctangent graph. So if I'm looking at values to the left of 0, the arctangent is negative. To the right of 0, the arctangent is positive. So if I understand my graphs, I can get this value very easy. Now my graph is going from decreasing to increasing, so it would be a minimum at x equals 0. So I plug in x equals 0 into the original equation, and that would give me my actual minimum value of 0 as well. So when is the tangent 0? That's at 0. 0 squared is 0, so there's the point 0, 0. So basic differentiation, when we just have basic polynomial functions or rational functions, that would be low, d, high. Functions involving radicals, you rewrite it and use chain rule. Transcendental functions, those are logarithms, exponentials, trig functions, inverse trig functions. So that's the difference in an algebraic and a transcendental. So your basic rules, these are all the rules that we have covered in derivatives. And the next slide, more derivatives, more derivatives, more derivatives. And again, you do not have to memorize number 19 through 24 at this point. In Cal 2, they do like you to have those memorized. And that ends our lesson. Good luck, guys. We'll see you tomorrow.